Hey, so this is the last, I guess, preparation presentation that we'll go through before the course next week. We're very excited to see you all on Wednesday and Thursday, where we're going to go through a lot of these things in a very systematic manner. And of course, we hope that that some of this preparation material has at least helped some of you to either climb the learning curve or to refresh a few fundamentals. Last week we talked about the so-called, among other things, we talked about the so-called formation and volume factor for gas condensates, which was this BGD over little rs term that had essentially this exact same units as the oil formation volume factor. What we're going to talk about this week is in place volumes. And related to that, we typically in university and in a lot of courses and whatnot, we learn about oil reservoirs and how we would calculate oil formation volume or use oil formation volume factors and solution GORs to calculate original oil and gas in place. And typically, we see or we use the equations that we have here. The so-called original oil in place is just the volume of oil down in the reservoir. So it's essentially the hydrocarbon pore volume divided by the initial formation volume factor for oil. And to calculate the original gas in place, we then multiply this particular original oil in place with the solution GOR. The problem is if you're talking about other type of fluid systems, such as a gas condensate fluid system or a two-phase system even, how would you actually then go about in a systematic manner to calculate those? And then it becomes a little bit more tricky and involved. But that's what we're actually going to try to just simplify in general today. So please try to follow this thought process. So what if we could actually use the exact same formulas that we use for the oil reservoir, which is essentially the hydrocarbon pore volume divided by the formation volume factor to get the oil in place. And then we do exactly the same thing for the gas in place. That we say that the original gas in place is equal to the original oil in place multiplied with some kind of GOR. Okay. That's very simple, and it would be great if we could use the exact same formula for every single well throughout our basin. And why is this relevant for unconventionals? Well, in unconventionals we have typically acreage that span a wide range of fluids. It can be everything from black oils to volatile oils, near critical fluids, gas condensates and whatnot, maybe even two-phase. So why can't we just in general use this as a systematic approach, and it makes all our lives simple. So what we need to actually get then is a way to calculate this volume factor and this GOR rigorously for all cases. Okay, the short answer to that is that that's actually done for us, and it's called the so-called total formation volume factor for on the formation volume factor side, and the equation looks like this. And just remember that the saturations here are given in percentage. So for a single phase oil, this equation would simplify to being the B subscript O, which is what we know. And for a single phase gas system, it was simplified to be the BGD over little rs, which we learned about last week. Okay, so it makes sense. And for a two-phase saturated case, let's say we have two phases down in the reservoir, the total formation volume factor will represent a saturation-weighted oil formation volume factor. Okay. Similarly on gas, for GOR, it's a little bit more involved, but we also, if we look at this equation right here, if we say that it's only a single phase gas system, this GOR would simplify to being the solution GOR, and for a single phase sorry, I meant to say for a single phase oil reservoir, it will simplify to be the solution GOR, and for a single phase gas system, it will simplify to becoming the 1 over little rs, which we also talked about last week. And again, for a two-phase saturated case, the total GOR will represent a saturation-weighted GOR. Okay, and with these two definitions, we can then go in and always use the same equation, and that will make our life simple. And we'll also do an exercise on this and also show that this is actually calculated automatically in Witsen PVT. And last, for those of you who are interested in the derivation of these equations, just send me an email and I'll send that you all